In this video, we'll start looking at double angle identities. So the question that we're going to be working with is we have a right triangle and we're given that the angle here we'll call theta, and then this side is 1 and this side is 6. So sorry that the figure's not really to scale. And then our right angle is here. And what we're asked to do is to find sine not of theta, but of 2 theta. Now you might look at this and say, well, wait a minute, where is the angle 2 theta? It's not even in this picture. And you're right, it isn't. So basically then, we could think of if you made a second copy of theta here, then this side would go way up even off the screen. So your gut might be say, oh, well, this should just be twice sine of theta, but if my picture is at all convincing, it's clearly a little different than that. So we've got work to do here. Now the question is, what is this? Now, in a way, we've actually already answered this question. Namely, we know, and this is going to be one of those times in mathematics where we do something evil, what is 2 theta anyway? Or for that matter, what is 2? And so we're going to think of 2 as being 1 plus 1. So not a huge shock. 1 plus 1 equals 2, and therefore I can rewrite 2 theta as being theta plus theta. But now I've got this expressed as an angle sum, and we had trigonometric identities from last section for how to do this, and so this would be sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. But in all 4 of these cases, the angle is theta because the 2 angles we started with there are theta. So these 2 terms are actually the same. And so what we've got here is a new identity. Sine, let's try that again. Sine of 2 theta equals 2 sine theta cosine theta. Okay, so let's just highlight that. Now, there are other trigonometric identities, so you might naturally ask, what is cosine of 2 theta? And that we'll look at separately in class. But for now, let's just try and answer the given question. So we've got this triangle. We're interested in what sine of 2 theta is. Now, we need to know information about sine theta and cos theta. And in order to do that, let me actually draw the triangle again. We knew we had 1 here, 6 here, and we need to know what the hypotenuse is. So, quick Pythagorean theorem, this would be the square root of 37, which is an ugly number, so we'll just leave it like that. So in this triangle, sine of 2 theta is 2 sine theta cos theta. And we know that in this triangle, sine theta is the opposite over the hypotenuse, so that's 1 over root 37. And cosine is the adjacent over the hypotenuse, so that's just 6 over root 37. The square roots cancel, and so we get 12 over 37. And that's basically it. So later we'll look at, in class, what do you do with the cosine of 2 theta, and then similarly tangent and secant and all the other stuff, and what other things can we do with these identities.